Hello. I've done this a few times before with other classes, but I've never done it with this. I'm sure there's a little bit of a lag, probably like a few seconds. Yeah, it's a few seconds, like 5-10 seconds. Yeah. Okay, bye. Aircraft departs an airport in the Mountain Standard Time Zone 16:15 Mountain Standard Time for a 2-hour, 15-minute flight to an airport located in the Pacific Standard Time Zone. The estimated time of the arrival destination airport should be 18:30 Pacific Standard Time, 17:30 Pacific Standard Time, 16:30 Pacific Standard Time. So we're going. I normally get these right. 16:15 Mountain Standard Time, and it's a 2-hour, 15-minute flight. And we're going to look at the figure here. Oh, that's not what I wanted to click. What I like to do is I like to put it all into International Coordinated Universal Time. Yeah, Coordinated Universal Time, and then go from there. So that's what we're going to do. So we're in Mountain Standard, and then we're going to, what did it say, Pacific? Mountain Standard to Pacific Standard. Okay, so that's just, okay, whoa, okay. 16:50 Mountain Standard, add 7 hours. Okay. The flight is 2 hours. So our landing time, Coordinated Universal, is going to be 24:15. And now we convert that back to Pacific Standard. So we're going to subtract 8. $16.15. I think. 16:30, because it's 15 minutes. Pacific Standard Time. I got it wrong. Add 7 hours. Oh, shit. Okay. I did my math wrong. All right, next question. Determine the magnetic heading for a flight from Major Airport Area 1 to Winnsboro Airport Area 2. The wind is from 340 at 12 knots, true airspeed is 36 knots, and magnetic variation is 6 degrees and 30 seconds east. Okay, magnetic heading. Let's look at it. We're going from Majors to Winnsboro. Area 2. 30-second break. Sing a song. Request a song, and I'll sing a song. We got two live viewers right now. I don't know who they are. I know it's Shakti. I don't know who else. Area 1, Majors Airport. Can't you hear that boom, 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 baby? That's super bass, boom, 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 baby. Super bass, boom, 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 boom. This one is for the boys with the boom system, top down AC with the cooler system. When he come up in the club, he be blazing up. Got stacks on deck like he's saving up. He ill, he bill, he might got a deal. Pop bottles and he got the right kind of bill. So it's section 1, right? Majors Airport, Area 1. Why can't I find Majors Airport on the sectional? Oh, there it is. Okay. It's a government airport. Going from Majors to Winnsboro. Wind is 340 at 12. True airspeed is 36 knots. Magnetic variation is 6 degrees. 30 seconds east. Okay. From Majors to Winnsboro. I'm still learning how to use this tool. It's like online study thing. Okay. Majors, Winnsboro. And now we should be able to look at this line. Yeah. Line. Okay, we'll just guess. This isn't even right. Okay, 0. So this is 0.90. 90. It's gonna be like 120 degrees maybe. Wind is 340 at 12. Okay. Heading means the direction that the nose of your aircraft is pointing. Course means the track that you trace over the ground where your aircraft actually goes. So for example, if you stand and face north and crab walk sideways to your right while continuing to face north, your heading would be north and your course would be northeast. Okay. Let me write that down. Heading course is trace over the ground. Both headings and courses can either be true or magnetic. True courses and headings are made related to true north. True north is the geographic North Pole, the point at the top where the lines of longitude converge and where the rotational axis of the Earth passes through. Magnetic courses and magnetic headings are made in relation to magnetic north. Magnetic North Pole is the place on Earth where the magnetic compass points to. It is close, but not exactly at the true North Pole. The difference between true north and magnetic north is called variation. Variation depends on where you are on the Earth when the measurement is being taken, as the exact location of magnetic North Pole and magnetic lines of force acting through it vary over time. Okay. When converting true to magnetic in the northern hemisphere, east is least and west is best. Subtract easterly variation, east is least. Add westerly variation, west is best. Okay. This tells us that when we convert from true to magnetic, we subtract easterly variation and correspondingly add westerly variation. Determine the true course from a chart. Parallel axis of the plotter with vertical line of longitude. True heading. Winds aloft are winds true. Compute true heading given the winds using the flight computer. Hello. Recall east is least and applying magnetic variation, convert to magnetic heading. Okay, does it walk through the math? Okay. Here's the steps to solve this problem. Step 1, we need to determine the true course. So let's look at that. The course line from Majors to Winnsboro is what I answered. It was like 100 degrees. I think I said like 110 or something. So that's close. Couldn't use the thing. 100 degrees. Use our E6B to compute the true heading given our wind speed and direction. Okay, place an aviation plotter on the course line, ideally near the midpoint of the course so that the center spot is both on the course line and on a true north-oriented black line of longitude. Oh, shit. Okay, sometimes it is impossible due to the way the chart happens to be drawn. In such cases, you may need to carefully shift the plotter to a line of longitude while being careful not to disturb its orientation. In this case, though, we will have a convenient line of longitude available close enough to the midpoint of the course line. And then we just read the resulting true course. In this case, it's 100 degrees. What was our original course line? So our true course is 100 degrees. Okay, and then step 2. That was all step 1. Yeah, that was all step 1. Okay. Given the true winds, determine true heading using the flight computer. Set the course to 100. Set the true airspeed to 36 knots. Draw a dot at the wind speed, in this case 12 knots, below the center. Here it is at 24. Put the wind direction at the top. Read the resulting wind correction angle from the side scale. 17 degrees left. Convert true heading to magnetic heading. Okay, we have computed a wind correction of 17 degrees to the left. Therefore, true heading is true course 100 minus 17, which means, because true heading is 83 degrees. 100 true course minus degrees of correction. we're converting from true to magnetic. So we subtract the easterly variation and add it to the westerly variation in this question context. The local magnetic variation is 6.5 degrees east. Hence, we subtract this easterly variation. 83 degrees true, heading minus 6.5 degrees easterly variation. Where did they get the easterly variation? Shit. So silly. We're at the end of showing you how to do the whole question. It says, while this question does exist in the FAA database, it is unlikely that you will see a question with an airspeed this slow if you're flying airplanes. There's no need to find/buy a slow speed E6B for your actual test. Okay. It is not milk. It is iced coffee or cold brew coffee from Starbucks. Let's try this problem. Let's try this again. I'm going to go through the whole thing while I did the first step. That was it, right? So I need to try it again. Let's go back. Let's see if we can calculate it. Okay. So I need to buy a flight computer. Still don't have one. An E6B, Amazon. E6B flight computer. $28. Here is a $12 one. Arrives. I need it sooner than that. I'm just going to spend the money and get it sooner, I guess. By Wednesday. $30. Okay. Alright, next question. That one sucked. Low-level turbulence can occur and icing can become hazardous in which type of fog? Upslope fog, rain-induced fog, steam fog. Low-level turbulence can occur and icing can become hazardous in which type of fog? I'm going to say rain-induced fog. It's not steam fog. Nice. See ya. Low-level turbulence can occur and icing can become hazardous. Fog is formed when water is humanized. It's commonly when cold air drifts across relatively warm water. turbulence can occur and icing can become hazardous in which type of fog? Steam fog. Steam fog is when cold air goes over relatively warm water. Okay. The greatest vortex strengths occur when the generating aircraft is heavy, dirty, and fast, heavy, clean, and slow, light, dirty, and fast. I remember this, but I don't remember it. It's gotta be heavy, dirty, and fast. Heavy, clean, and slow. Damn! Heavy, clean, and slow. The degenerated the creation of a pressure differential over the wing surface. The lowest pressure occurs at the upper wing level and the highest pressure occurs under the wing. Yes, the pressure differential triggers the roll-up of airflow aft the wing, resulting in swirling air masses traveling down. The wake consists of two counter-rotating cylindrical vortices. Most of the energy lies within a few feet of the center of each vortex. Wake turbulence has historically been thought of as only a function of aircraft weight. Recent research considers additional parameters such as speed, aspects of the wing, wake decay rates, and aircraft resistance to wake, to name just a few. The vortex characteristics of any aircraft will be changed with the extension of flaps or other wing configuration devices, as well as changing speed. However, the basic factors are weight, speed, and the vortex. Weight and speed. The vortex strength increases proportionally with an increase in aircraft operating weight, decrease in speed. The greatest vortex strength occurs when the generating aircraft is heavy, slow, and clean, since turbulence from a dirty aircraft configuration hastens wake decay. Okay, that makes sense. Wow. Okay. What is the approximate position of the aircraft if the VOR receivers indicate, I hate VOR questions, indicate the 320-degree radial of Savannah Vortac, Area 3, and the 184-degree radial of Allendale VOR, Area 1? These questions. VOR indicates 320 degrees radial. Savannah. VOR. Radial of Allendale. let me try this. 2 flags. So we're using let me just draw this. 2 flag. So we're going to use the top half. And now it's full deflection to the left. So we're going to cross out the right half. We're only using the left. We're going to draw a line at about 45. I'm looking at a heading of like 240 degrees. So that would be, there's the station, and we have to fly at a heading of 240 to get there. Look, we have to fly at a heading of 240. We're like southwest of the station, or no, we're northeast of the station. To fly at a heading of 240 to get there. Let's check it for right. Fuck. I did it wrong. Okay. Just the top half, too. Full deflection to the left, crossing out the right. And we're looking at 45 from there, so it's 330, 330 degrees. So this is 0, 90, 180. We want to fly a heading of 330, right? Yeah, about 325 maybe. Okay, so we're southeast. Let me do this one. We're using just the bottom half. We got full left deflection, so we're using just the right half, bottom right. Our heading should be like 100 degrees. So if we want our heading to be 100 degrees, we are northwest of the airport. Nice. I got that one. Okay, let's get back to the exam test, practice test. What is the approximate position of the aircraft if the VOR indicates 320 radial of Savannah Vortac, Area 3, and 180 radial of Allendale VOR, Area 1? I should only have to do one. Oh, no, I can do both. Okay, so 320 degrees radial Savannah, and 184 radial Allendale. So Allendale's area 1, Savannah Vortac is area 3. Okay. Savannah Vortac, Class C airspace. Vortex. Yeah. Yeah. Okay. So we're reading 320 to get to Vortex Savannah. So that means we're southeast of Savannah Vortex. And 184 to Allendale, area 1. So I can draw a line on here. Actually, there's not much location for where this should be, but we will do it. I think this works. Okay. Something like that. That's the heading. I should have to be getting there. Oh, no. Okay. So I'm actually north. I am northeast. Yeah. Okay, my bad. It's like roughly. No. No, I am southeast. Okay. Definitely southeast. And then I'm looking at Allendale. And we go 184 to get to Allendale. So if I had a heading of 184 to get to Allendale. Like directly north of Allendale. Okay. North of Allendale, southeast of Savannah. So now our options are the town of Springfield, Overbridge Airport, southeast of Guyton, southeast of Guyton. So now I'm going to look at these on the map and see what we're working with. Okay. Okay. Let me look at this again. So our radial to get to Savannah is 320. So I'm southeast of Savannah. For sure. But then our radial to get to Allendale is 184. So I'm north of Allendale. How am I southeast of Savannah and northeast of Allendale? It doesn't make any sense. Am I doing one of these wrong? My heading has to be... No, that makes perfect sense. 180 radial. 320 radial. Okay, I know I'm not over Springfield. So that's south. Okay, southeast Guyton. Let's look at the exponent. Oh shit, I didn't even have to do all that. It shows the radials on here. Oh, I didn't realize the map was also adjusted. 27 radial. Okay, let's look at the map again and figure it out. Okay, 180 from Savannah. We can draw that line there, and then just where the two lines intersect will be good. There. Sure. And then oh, 184. Okay. So we'll do this. There. And then the three, was it 320 from Savannah? So there's 300, there's 330. We're doing 320, so I guess it'd be like right there. Yeah, and that makes sense too. Southeast of Gaiden. Cool. Cool. VOR. It's an instrument. VOR is an instrument used to like airports have a radio signal that they send out called a VOR. And there's an instrument in an airplane that picks up on that radio signal, and it will tell you which direction heading you have to use to get to that airport. But it's convoluted. It sounds like it should be easy, but it's a little weird. If someone doesn't walk you, like, it's not something you could just look at and figure out. Someone has to walk you through it the first time. But I never used them in gliders. You don't use it, but it's still on the test. So that's why I have to study. Okay, this one's easy. Altimeter 2 indicates, okay, 2,500 feet, 1,500 feet. Illustration 2 means, okay, holds. There's an airplane in the pattern. Hold position. Yay, haha. Okay, bye, Shakti. We still have one viewer here besides Shakti, whoever it may be. Dave sending me a video. A recreational pilot has a flight review on August 8th this year. When is his next flight review required? It's called a biannual. 2 years. So the end of the month, 2 years later, August 31st, 2 years later. Everything with the FAA is at the end of the month. Almost nothing happens the exact day. So even medical, end of the month from the month you got it. It works like car inspections. Like your inspection's not out until the end of the month, no matter which time during the month last year you got it. What preparation should a pilot make to adapt the eyes for night flying? Avoid bright white lights at least 30 minutes before the flight. Wear sunglasses after sunset until ready for the flight. Avoid red lights for at least 30 minutes before the flight. I'm going to say A, avoid bright white lights for at least 30 minutes before the flight. That is correct. Now, if that's one that I got right, and I kind of know the answer, but it was like a half guess and only I know that, I'm going to read the question again, read the answer, read the question again, read the answer. So what preparation should a pilot make to adapt the eyes for night flying? Avoid bright white lights for at least 30 minutes before the flight. What preparation should a pilot make to adapt the eyes for night flying? Avoid bright white lights at least 30 minutes before the flight. Okay. During a ground launch, how is the airspeed of a glider increased? A, lower the nose. B, raise the nose. C, increase the speed of the vehicle or winch. C, increase the speed of the vehicle or winch. No, raise the nose. Okay, weird. The airspeed of a glider is increased by raising the nose during a ground launch. Oh, ground launch. That's what I missed. I'm an idiot. The airspeed of a glider is. You gotta read the actual question. That's some of these FAA questions. Like, they're made to confuse. They ask weird things in weird ways. So you just gotta make sure you really read the question. You can't like half read it. The pitch altitude relationship during the launch. Increase the speed during the launch. Pulling back on the stick tends to increase airspeed. Pushing forward tends to, This is the opposite of a normal pitch airspeed relationship when the wings of the glider divert air towards the force of the vehicle launching. The wings of the glider divert the towing force of the vehicle launch in an upward direction, enabling a rapid climb. The greater the diversion of the horizontal pulling power to the vertical lifting power, the faster the airspeed is. This is true if the tow vehicle is powerful enough to meet the energy demands of the glider. Okay, cool. Pilots are more subject to spatial disorientation if A, visual clues are taken away. They are not in instrument meteorological conditions. B, they ignore the sensations of muscles and inner ear. C, eyes are moved often in the process of cross-checking flight instruments. Yeah, it makes sense. So again, I kind of guessed on that one, so I'm going to read it again. Pilots are more subject to spatial disorientation if A, visual cues are taken away as they are in instrument meteorological conditions. IMC, instrument meteorological conditions. So what that means is like, if you're in a cloud, if you get like lost in a cloud and you can't see things, you actually lose orientation of yourself very quickly, and you could easily just like fall out of the sky. It happens all the time. People get in big trouble because it's hard to figure out where you're going, which direction you're heading when you can't see and you don't have the instruments for it. That's how planes crash a lot. This is a pretty expansive, most dangerous flying in the clouds, visibility and all cues out there. VFR pilots and IMC. Yep. Pilots training for receive a few hours of training under the hood. Yes. Finally, it's worth noting that many pilots who get a PFR into IMC trouble are actually instrument-rated pilots who are slow to transition to proper IFR flights and operating procedures as they find themselves flying into disorientated weather conditions. Accidents happen. Our pilots have placed an unrealistic trust in their instrument flight training, believing this to allow them to operate safely with a minimum level of visual references, but still VFR. Such overestimation can lead to tragic results. VFR into IMC is very dangerous. If you find yourself getting into such a situation, be sure to reconstruct the chain of events that got you there and make sure it never happens again. Incorrect answers. They ignore the sensations of the inner ear and muscles. Is incorrect. Pilots should ignore the sensations of muscles in the inner ear when flying IMC, as they give many false or misleading clues. Yeah. Eyes are often moved to the process of cross-checking the flight instruments. Is incorrect. Pilots are taught to maintain an instrument scan while IMC to constantly cross-check all parameters of flight. Sure. Who should not participate in the land and hold short operation program? Military pilots, recreational pilots only, student pilots. I'll read it again before I answer. Who should not participate in the land and hold short operations program? Student pilots. Yes. When warm, moist, stable air flows upslope, it A. produces stratus-type clouds, B. causes showers and thunderstorms, C. develops convective turbulence. It is A. produces stratus-type clouds. What's really tipping me off there is stable air. So showers and thunderstorms are caused by unstable air, and convective turbulence is caused by unstable air. Yep. So let's read that one more time. When moist, stable air flows upslope, it A. produces stratus-type clouds. Stratus, if you see like stratus clouds, it means the air is very calm. Not much going on. Okay, next question. Thunderstorms which greatly produce the most intense hazard to aircraft are squirrel line thunderstorms, warm front thunderstorms, steady state thunderstorms. Oh geez, I honestly don't know. So I'm gonna guess, and I'm gonna say it's not steady state thunderstorms. I'm gonna say it's probably warm front thunderstorms or squall line thunderstorms. Let's go squall line. Squall line is correct, but we're gonna read the explanation of that. Okay, squall line, or a non-frontal narrow band of active thunderstorms, often develops ahead of cold fronts in moist, unstable air. It develops in unstable air far removed from any front. The line may be too long to easily detour and too wide and severe to penetrate. Okay, so that's what's going on. It often contains severe steady-state thunderstorms and presents the single most intense weather hazard to aircraft. It usually forms rapidly, generally reaching maximum intensity during the late afternoon and a few hours before darkness. First few hours of darkness, rather. Sorry. Okay. So a squall line, non-frontal, narrow band of active thunderstorms. And I think we're looking at a picture of it here. Squall line. Okay. I think we just need to know that squall line is the most dangerous. So thunderstorms, let's read it again. Thunderstorms, which generally produce the most intense hazard to aircraft, are squall line thunderstorms. Thunderstorms, which generally produce the most intense hazard to aircraft, are squall line thunderstorms. Next question. The wind direction and velocity at KJFK is from, okay, this is a METAR question. I can totally do this one easily. From Shakti. Let's see. You should watch. Anything happens, I love you. It's all over TikTok. What? You should watch it in person, if anything. But if you watch it, I don't want you to watch it again, because then it's not as scary. Okay. Wind direction and velocity from KJFK. 180 at 4. I think all METAR is true. Yeah, so it's 180 at 4 knots. True. Yeah, all METAR is true. So we can think about that again. Direction and velocity from KJFK. I'm looking at the METAR information. 121. So this first part is the date and time. 121853 Zulu. So that means I think that was like 12:18 at 5:30 maybe. I think that's what that is. 18004 knots is 180 knots true, 180 degrees true at 4 knots. 1/2 SM is 1/2 statute miles of visibility. Fog, FG is fog. I'm looking at some other things here. R is like, this is like convective flow rates or something. I'm not sure. I got the question right. Okay, next. The WINGS recruitment training system is, I have no idea what this is. Hourly based, one-time training event, proficiency and knowledge based. I literally have no idea what the WINGS training system is. So we're going to say proficiency and knowledge based, like everything in the FAA. And that is correct, I guess. Let's read what this is. The WINGS pilot proficiency program is based on the premise that when you maintain currency and proficiency in the basics of flight, you will enjoy a safe and stress-free flying experience. Requirements, which include use-specific flight maneuvers, airman certification standards, are established for airplanes, seaplanes, amphibians, rotorcraft, gliders lighter than air, powered parachutes, weight shift control, light sport aircraft. You may select a category and class of aircraft in which you wish to receive your training, which demonstrate your flight proficiency. All training must place special emphasis on safety of flight operations. Proficiency must be demonstrated to the applicable standard of the practical test standards or industry course completion standards. WINGS Pilot Proficiency Program is designed to encourage you to participate in an ongoing training program that will provide an opportunity to fly on a regular basis with an authorized instructor. With this in mind, 3 levels. Flight designed around flexibility and efficiency. So what is it? It's just a training program. Addresses accident causes once every 12 calendar months. Ensures a pilot is aware of accident causes. Possible. 3 knowledge credits. Okay. Advanced level. This level is advanced for pilots who want to training program. Take them a step above basic. Master level. Light sport aircraft cannot be used for master level wings. Okay, so let's just read the question again and the answer again. The WINGS recruitment training system is proficiency and knowledge based. The WINGS recruitment training system is proficiency and knowledge based, like most things in the FAA. Right. The visibility and cloud clearance requirements to operate VFR during daylight hours over Sandport Airport at 1,200 feet AGL are, refer to figure 22, area 1. So we're looking at, this is, what class is this? A, nope, not A. B is like big cities, New York, Philadelphia, no. C, this is not class C airspace because it would show 2 circles. It could be D because I think it's still controlled. I think it's class D airspace. So from here, we should be thinking about class D airspace minimum flight requirements for VFR flight. And I'm horrible at these. So, okay. For 1,200 feet AGL. It's probably 1 mile in clear clouds. That's honestly probably it. No, 3 miles, 1,000 feet. Oh, I should have known that. God damn it. 3 miles and 1,000 feet above, 500 feet below, and 2,000 feet horizontally from each cloud. It's Class E airspace. The magented area lines implies that Class E airspace begins at 700 feet AGL in this area. Right. Therefore, the airspace at 1,200 feet AGL over Sandport area is Class E. E is everywhere. Right. Okay. Magenta line. Shaded magenta line implies that Class E airspace begins at, so below 700 feet. Class E airspace with a floor at 700 feet. Above surface that laterally abuts Class G airspace. What? Class E airspace with floor 700 feet. Above surface that laterally abuts 1,200 feet or higher Class E airspace. What is going on? I really just need to read. No, you know what I should do? I should just write down the controlled airspace chart and practice it. That might be. Let's look at this. Okay. So what class airspace is this? Class E begins at 700. Okay, and then the minimum flight requirements for Class E airspace. E is like still controlled airspace. Okay, less than 1,000 or 10,000 feet MSL. 1,000 feet above, 200 feet below, 500 feet below, 2,000 horizontal. That's what we fly too. Yeah, that's the same for Class G. Day and night. The only spot Class G would be different is if it's more than 1,200 feet above the surface and at or above 10,000 feet MSL. Okay, if you're really high in the air, the visibility in Class G airspace has to be 5 statute miles, and it's 1,000 feet above, 1,000 feet below, and 1 statute mile horizontal. So you gotta really avoid clouds if you're in Class G above the clouds. Or, I mean, pretty high up, not above the clouds, but really avoid them if you're high in Class G. And Class E. Class E and Class G actually have the same, yeah, at or above 10,000 feet MSL is the same. Okay. And at night, okay, cool. That's not too bad, actually. I'm gonna take a picture of that. See if I just do pictures of that. is the most confusing graph I've ever seen. I'm not even going to look at that right now. That is just too much for me. Okay. So let's go back and read the question and the answer again. The visibility and cloud clearance operate VFR during daylight hours over Sandport Airport at 1,200 feet AGL. We should look at this and we should know that this is Class E airspace. Shaded magenta line means Class E airspace. Class E airspace has the same minimum flight requirement VFR full as Class G. So 3 statute miles, 1,000 feet above, 500 below, and 2,000 feet horizontally of clouds. And we should be able to look at this. And Class G, actually, it's different. Flight visibility is different. Flight visibility in Class G is higher, or flight visibility in Class E is higher than Class G. In Class G, minimum flight visibility is 1 statute mile. In Class E, it is 3 statute miles. That's the only difference. Okay. The angle of attack at which an airplane wing stalls is increase if the CG is moved forward. Change with an increase in gross weight. Nope. Remain the same regardless of gross weight. I think it remains the same regardless of gross weight. Yes, correct. Let's go back and read that a few more times. The angle of attack at which an airplane wing stalls will, remain the same regardless of gross weight. The angle of attack at which an airplane wing stalls will remain the same regardless of gross weight. Okay, next question. Which approach and landing objective is assured when the pilot remains on the proper glide path of the VASI? Safe obstruction clearance in the approach area, course guidance from visual descent point to touchdown, continuation of course guidance after transition to VFR. Which approach and landing objective is ensured when the pilot remains on the proper glide path of the VASI? Safe obstructed clearance in the approach area. Course guidance from the visual descent path to touchdown. Continuation of course guidance after transition of VFR. I don't think it's this last one. I think it's one of these first two. Course obstruction clearance in the approach area, course guidance from visual descent point to touchdown. Okay, I got it right. I said it was safe obstruction clearance in the approach area, but I don't even know what VASI is, so we're going to read again. Oh, okay, I do know what this is. Visual approach slope indicator. On glide path is red over white. Below glide path is red, red. Above glide path is white, white. White, I just think white's in the clouds. You're too high. Red, you're going to die. You're too low. So, okay. VASI installation, the most common visual glide path systems in use. VASI obstruction clearance within 10 degrees of extended runway center, up to 4 nautical miles from the runway threshold. VASI consists of flight units arranged in bars, 2-bar and 3-bar VASI. 2-bar VASI has near and far lights, and the 3-bar VASI has near, middle, and far lights. I don't know what that means. 2-bar VASI installations provide a visual glide path that is normally set to 3 degrees. The 3-bar system includes 2 glide paths. You want red over white. Red, red's too high. White, white's too low. No, white, white's too high. Sorry. White, white's in the clouds. Red, red's on the ground. So red over white's better. So let's read the question again, now that we know what VASI is. Which approach and landing objectives is ensured when the pilot remains on the proper glide path of the VASI? Safe obstruction clearance in the approach area. Yes, that makes sense. Continuation of course guidance after transition to VFR. We said nothing about flying IFR, transition to VFR. So that doesn't make sense. Course guidance from the visual descent point to the touchdown. Well, let's see. It explains why the wrong answers are wrong. You may find the following incorrect answers on the actual test. Runway indication and course guidance. Wrong because no runway ID is provided. Moreover, at most VSI provides is visual course guidance in the approach area. It does not provide any lateral course guidance. Yes. Lateral course guidance to the runway. Wrong because it doesn't provide any lateral course guidance. Cool. Continuation of course guidance after transition to VFR. This odd wording seems to suggest that an instrument precision glide slope, for example, in ILS glide slope, necessarily corresponds to a VASI glide slope. It does not. I don't know what this is. ILS? Precision instrument approach system that normally consists of the following electronic components: locator, glide slope, outer marker, middle marker, and approach lights. Instrument landing system. Sorry, I don't know why that did it weird. Okay, instrument landing system. Radar based, allowing ILS equipped aircraft to find a runway and land when clouds may be as low as 200 feet. Okay. Course guidance from visual descent point to touchdown. There is no relationship from any VDP to touchdown with the VASI. VDP being visual descent point. Defined point on the final approach course of a non-precision straight-in approach procedure from which normal descent from the MDA to the runway point may be commenced, provided the approach threshold to the runway. Okay. Winds at 5,000 feet AGL on a particular flight are southwesterly, while most of the surface winds are southerly. This difference in direction is primarily due to A. Stronger Coriolis force at the surface. B. Friction between the wind and the surface. C. Stronger pressure gradient at higher altitudes. I think it's C. Winds at 5,000 feet AGL, above ground level, on a particular flight are southwesterly to the southwest, while most of the surface winds are southerly. Stronger pressure gradient at higher altitude. Wrong. Friction between the wind and the surface. Okay. There's a drag on the wind blowing over it. The friction can act to change the wind's direction and slow it down. Actually, the difference in terrain conditions affects how much friction is exerted. For example, calm ocean surface is pretty smooth, so the wind blowing over it does not move up and down. Trust hills and forests, so don't change direction much more. Coriolis force. In general atmospheric circulation theory, areas of low pressure exist over the equatorial regions and high pressure areas exist over the polar regions due to difference in temperature. The resulting low pressure allows the high pressure air at the poles to flow over the planet's surface towards the equator. While this pattern of circulation is correct in theory, the circulation of the air is modified by several forces, the most important of which is the rotation of the Earth. The force created by the rotation of the Earth is known as the Coriolis force. The force is not predictable to humans as they walk around because humans move, or perceptible, to humans as they walk around because humans move slowly and travel relatively short distances compared to the size and rotation and rate of the Earth. However, Coriolis force significantly affects the motion of large distances, such as an air mass or body of water. Coriolis force deflects air to the right in the northern hemisphere, causing it to flow a curved path instead of a straight line. The amount of reflection differs depending on the latitude. It is the greatest at the poles and diminishes towards zero at the equator, right? Because in the northern hemisphere, toilets flush to the right, and in the southern hemisphere, they flush to the left. And you can remember that. Well, we can remember that the forces are less at the equator because that's where the switch happens. So, of course, the force would be less. Okay, cool. So, let's read this question again. Winds of 5,000 feet AGL on a particular day are southwesterly, while most of the surface winds are southerly. This difference in direction is primarily due to friction between the wind and the surface. Because, okay, so now we know why the other answers are wrong. Strong Coriolis force at the surface. Coriolis force doesn't vary from surface. It varies from lines of longitude, being the least impactful at the equator, most impactful at the poles. Okay, the other wrong answer would be stronger pressure gradient at higher altitudes. I don't know why that's wrong, so we should read the explanation again. But let's read the question and the answer right. So, winds at 5,000 feet AGL on a particular flight are southwesterly, while most of the surface winds are southerly. This difference in direction is primarily due to friction between the wind and the surface. Friction between the wind and the surface. I don't know why that's wrong. Moving on. Which environment is most conducive to frost formation? Dew point on the surface is below freezing. Dew point above is freezing. Dew point on the surface is below freezing. Dew point above is freezing. Surface temperature is below freezing. Air temperature is below freezing. Surface temperature is above freezing. Air temperature is below freezing. Dew point on the surface is below freezing. Dew point is above freezing. Surface temperature is below freezing. Air temperature is below freezing. Surface temperature is above freezing. Surface temperature is above freezing. Air temperature is below freezing. Oh, no. Surface temperature is below freezing. Air temperature is below freezing. Okay. Frost are the formation of ice crystals on the ground or other surfaces of solid objects below the freezing point of water. It develops in the Arctic coastal areas during spring, fall, and winter. On cool, calm, clear summer nights, the temperature on the ground and objects on the surface can cause temperatures of the surrounding air to drop below the dew point. Turn up the heat here a little bit. Hey, Shakti, what's up? Can I mute my mic here? I am, yeah. I don't know if I can mute my mic. That's fine. I don't think anyone's watching. What's up?
Something's wrong with the record audio or something. I can't hear you.
You can't hear me at all? Hold on, wait. Call.
No.
Hang up and call back. Is this better? Hey, Dave.
Over
Mr. Famous, anyone else come watch your live?
It says someone's watching it right now, but I don't know.
I was gonna say it looks like very productive. He's here.
No, I was doing really good work actually.
It's true.
What'd you get?
I'm still going
You've
through.
been
I didn't even
live?
make through a whole thing. I'm
For
an hour and a half in, and I've like every question I like read the entire explanation. And
What you got so far?
I don't know. Low.
Should name this Joey Fails Practical Exam.
Yeah. What, you got bored watching TV or what?
Yeah.
So you came to bother me?
Yeah.
All right, Chickty, I'm going to go. I'll call you back.
Yeah.
Okay, I love you, bye.
Laying in bed. That's what she called you.
Let me like,
Yeah, everyone wants to be around me.
What was that question on?
Frost. Which environment is most conducive to the formation of frost? I said surface temperature is above freezing, air temperature is below freezing. Because I figured if you're at the surface and
Oh,
water
that's icing.
with moisture in the air,
Is dew point surface below freezing?
it's no. Surface temperature is below freezing, air temperature is below freezing.
Oh, so it's cold out.
Frost is the formation of ice crystals on the ground surface and other object below the freezing point of water. Air temperature is below freezing. The moisture is deposited in the form of frost. It's basically just saying if it's cold.
If it's really cold, below freezing cold.
Yeah, I agree. Each person who holds a pilot certificate or medical certificate shall present it for inspection upon the request of any authorized representative of the Department of Transportation, person in position of authority, local law enforcement officer, Department of Transportation.
I think it's
Local law enforcement officer. Ugh. Okay. This permits to series of FARs inspection of certificate. Each person who holds an airman certificate, medical certificate, authorization, or license part must present it for inspection upon a request from the administrator, an authorized representative of the National Transportation Safety Board, or any federal, local, or state. Any federal, state, or local law enforcement officer. Okay, so I go back and I read it again. Each person who holds a pilot certificate or medical certificate shall present it for inspection upon the request of any local law enforcement officer. Under what conditions may objects be dropped from an aircraft if prior permission is received from the FAA? Only in emergency if precautions are taken to avoid injury or damage to persons, property on the surface. Yep. The conditions necessary to the formation of cumulonimbus clouds are a lifting action and either stable or unstable air. Unstable air containing an excess
Oh,
of
did you watch that
condensation
video I sent you?
Unstable moist air. Unstable moist air. No, not yet. I'm
Definitely.
doing this.
Alright. Kind of related.
It is not related to passing the practical, not the written test. CG is located aft of the CG limit. One undesirable flight characteristic of pilot may experience desirable would be takeoff, stalling speed, difficulty recovering from a stalled condition. Difficulty recovering from a stalled condition. 4 is forward, aft is back. Yep.
Yeah.
Just double checking. The wind is shown by the landing direction indicator. A pilot should land on. Oh, shoot. Okay. I think this means the wind is coming from this direction. So we want to land into the wind. We can't land on this runway. It has an X on it. So we're landing here. And we want to land.
It should be 18.
Hold on. Stop, Dave. You're not taking it.
Well, you can't Google the thing.
Stop. I'm figuring it out. I just want to know which way it means the wind's coming from.
Well, it'll
Is it
tell
coming-
you as soon as you answer it.
Okay, Dave, I understand that. I think it's coming from this direction. So I want to land 18.
Yeah.
And expect a crosswind from the right. Yeah.
Ah.
Point to the direction that the wind is coming from. I thought so.
Right, but look at what the other symbol means. On
What,
which
these?
traffic to go in.
Yeah, I know that. This is the right hand pattern for 18.
Yeah.
This is a left hand pattern for 22, but like I said, these are closed.
Right.
The X.
I did not know about the
Tetrahedron. T.
I guess the markings next to it.
These?
Yeah, I didn't know.
Yeah, they correspond to the runway traffic patterns. What should be the indication on the magnetic compass as you roll into a standard rate of turn from a slight south heading in northwest. Forget the moniker.
I think I know the answer.
Okay, Dave, you should just leave then. I literally didn't ask you. You're just distracting me at this point.
Not the one I would have guessed, actually. What was the bottom one?